It's time for another math easy solution. We're going to discuss some examples using the chain rule for derivatives. Basically look at part 1 of this series because I'm going to do a couple more videos in later videos. Basically in my earlier video I went over the proof over the chain rule, but did not do too many examples, so I'm going to go over them right now. So you can see the proof in the video links below in the related videos. Basically I want to go over a quick recap before I get to the examples. Basically the chain rule states if you have a function within a function, let's say like y equals f of g of x, so this function inside this function, and then the derivative in terms of x, or dy over dx, just equal to the derivative of f in terms of g, or df over dg, times it by derivative of g basically the derivative of g of x in terms of x, or dg over dx. So just multiply like that, or you can write it in this form: y prime equals f prime times g prime. So the examples I want to go over is these right here. First one, y equals x squared plus 1, and the second, y equals sine x squared, and then y equals sine squared of x. So if we go over the first example, y equals square root x squared plus 1, as you can see, this could be written as two functions right here. So you could write y equals to square root of g, and g is equal to, well, x squared plus 1 right here. So then basically you would take the derivative in terms of g, multiply by derivative of g of x in terms of x right here. So in other words, we would take the outer derivative and then multiply by the inner derivative. So this one right here, this could be also written as y equals x squared plus 1 to the power of 1 over 2, the same thing as square root. And then you could use the power rule for derivatives to get the first derivative in terms of g, which is x squared plus 1. And you can see the proof for that in the video links below. I did that proof for power rule as well. So dy over dx, or equals to y prime, is equals to, well, derivative of the outer one, so we bring this 1 over 2 down, x squared plus 1, then we have to subtract by 1 on the top, so 1 over 2 minus 1, that just equals to negative 1 over 2, and then times it by the inner derivative, or the g of x, derivative of g of x, which is just going to be, well, derivative of x squared is just 2x, and then derivative of 1, that's just 0. So we just have a 2x right here. So this is our answer. We could leave it like this, or we could simplify this further. We could cancel the 2's and bring this square, make this a positive root by putting it below a positive power. So we get y prime is equal to, the 2's cancel, x over square root x plus 1 right here. So or that's the same thing as putting it at the below, or x squared plus 1 to the power of negative 1 over 2. So this is our answer right here. So now let's look at example 2 right here. An example 2, there's two parts: y equals sine x squared and y equals sine squared of x right here. Yeah, so the first example basically states y equals sine of x squared. So as you can see, there's two functions in this one, so this could be written as basically f of g, which is now basically g is equal to x squared, and f is basically, yeah, it's just equal to sine right here, so sine of g, etc., or y equals sine of g, etc. So basically there's the outer function is the sine, the inner one is this g of x, which is the x squared. So again, we take derivative of the outer one, which is the sine, so then dy over dx is equal to derivative of sine. We know that from my earlier video I showed that derivative of sine is just cosine. So we put cosine, and then we just put in the g, because remember it's in terms of g, so we put in x squared. That's g. Now we have to multiply by the inner. So the inner one, the derivative of this one, is just 2x. So there's our answer actually, just so we don't need to do anything further. So that is our answer. But now the tricky one is when we look at part B, which is y equals sine squared of x. So now this is a bit different here. This one you could also write it as basically, this just means sine of x to the power of 2. So this is exactly the same thing as this means the same thing. So now our outer function is actually this outer power right here. So we could write it as y is equal to, well, g squared, where g is equal to sine of x. So now we have g as sine of x, where the other one we had y equals f equals basically sine of g. So now we have this case. So now we take the outer derivative using power rule, and now this will just be dy over dx is equal to, we bring down the 2, so then we write sine of x to the power of, well, 2 minus 1, that is basically just 1, so that's it, and then we multiply by the inner derivative of the sine squared, that is just cosine of x right here. So this is all, so we just are ended up with this right here. Yeah, and if you remember the trig identity, this is the same thing as basically sine of 2x. This is just a trig identity. You can see this in the video link below for the proof. So this is the same thing. And anyways, that's all for today. If you learn from these pretty useful examples on using the chain rule, basically never always go from outside to inside when you take derivatives. And every time you have an inside function, you have to always take derivatives as well, basically following this chain rule. So there's a chain of derivatives. So there's inside. If you have 3, if this x was in terms of, let's say, a, then you would have to have another x prime in terms of a. So anyways, that's all for today. If you learned from this video, and remember, you can always download these exact notes in the Dropbox link below, and stay tuned for another math easy solution.